Hi folks, welcome back to Math with Captain Rod. I'm making this video here to help teach you how to graph ellipses. Specifically in this video we're going to talk about just ellipses that are centered at the origin. So for starters, let's kind of chat about what an ellipse is. So if you pay attention to this geometry here, right, we would normally call that a circle as long as this thing is uniform. If I change the dimensions of it, you know, maybe something like this, or something like this, I get an example of a geometry called an ellipse. Now, the standard form for an ellipse, which, whoops, I've got that written over here. Let's redo this. Get that kind of out of the way. The equation for the standard form of an ellipse looks like this. Whoops. X squared over some number squared plus y squared over another value squared is equal to 1. Now, these values a and b, you know, these are typically, you know, these are positive numbers here because this is a squared and this is b squared. The a's and b's kind of dictate the geometry of the ellipse. If the a is bigger than b, I'll just do this over here, you get an ellipse with this type of shape. It is like a circle that's horizontally stretched. If the b is bigger than a, you get an ellipse that looks like this, vertically stretched. All right, so I'm going to go through some examples of sketching graphs of ellipses. All right, I'm going to go ahead and put a coordinate system here. I guess I'll use that dot there. Okay, and again, I'm just going to sketch quick sketches, and we're going to look at some examples. All right, so the examples I'm going to look at are on page 485 in your college algebra textbook. 485. And whoops, I'm sorry, 484. 484. And we'll take a look at number 4, where it says, all right, x squared over 4 plus y squared over 25 is equal to 1. So this is an ellipse centered at the origin, right? If it wasn't centered at the origin, the standard form looks slightly different. I'm going to go ahead and write that up here. The standard form of an ellipse centered at some other point. Oops. Looks like this. This is the general form for an ellipse centered at the point HK. All the examples here on page 484 are centered at the origin, because when you compare these two, you know, there is no h and k. So this guy right here is an ellipse centered at the origin. Now you'll notice that the b squared is bigger, so this thing's going to look like, you know, stretched out something like this. And usually what I do with these is I just get myself some points. They're very easy to get. If we set x equal to 0, this equation is now going to read y squared over 25 equals 1. Solve this for y. We get y squared is 25, so y is plus or minus 5. So we actually have 2 points that we can put on here. 0, 5, right? So 0, 1, 2, 3, 4, 5. And 0, minus 5. 1, 2, 3, 4, 5. Okay. Now we can get another set of points by setting y equal to 0. So if we force y to 0, this equation is now going to read x squared over 4 equals 1. It's pretty easy to solve that for x. So x squared is equal to 4. So x is equal to plus or minus 2. So the point 2, 0 is on the ellipse. 1, 2, 0. And the point minus 2, 0 is on the ellipse. 1, 2, 0. And that's pretty well enough here to kind of connect the dots. So we have this basically vertically stretched circle. Okay. And there's an example of graphing an ellipse. And honestly, that's probably enough examples for these. These are pretty darn simple to graph. So purpose of this video is just to provide examples of how to graph ellipses that are centered at the origin. The equations will take this form. It's really just pretty much as simple as set x to 0, find the 2 y values. Set y to 0, find the 2 x values. That's usually enough to sketch it. Hope that this video helps. Have a great day.